deleting, actually if it is here also, when it is first node or it is null means it is empty list, deletion is not possible. If it is not empty, you have to create a node pointer temp and initialize with head and check whether temp of next, beginning of the node, right? So you have to check whether the list contains many nodes or only one node. If it is only node, once again your list will become empty after deleting that beginning head node. Else the head node will take the position of the next node. So here how you are doing is, for example, if 1 2 3, so in this case there are 3 nodes. So if I delete 1, my next head node will become 2. That's all. So in this case, you can see here, I think it's not moving. Yeah, it is assigning to head, and your this is temp. Head is assigned to temp, and now once again, what you'll do? Your head will become, this head will become the temp of next. That is, 1 is deleted, and you can free the temp. Now taking to this line, so now this is the pointer. See, after 1 is deleted, your head will become this 2. 2 is now the head position. So here you see, first checking is head is null. If head is null, list is empty. Else, assign the head to the temp, head to temp, and here it should be temp of next. Okay, so it is equal to null. Your head is null. That is, this is like it is the first node. If it is, that is the first node, what will happen is your head will be the null part. That is, no more elements in the list, and free the temp. Else you have multiple elements in the list. You are deleting the beginning of the head. That is head node. Beginning of the list means head node you are deleting now. Next node should have the hold the head position now. So your head will become temp of next. Okay, and free the temp. Once head moves to temp of next, you can free the temp as in the previous diagram. Here this was temp. Now I am going to delete 1 now. So before deleting, what I have to do is I will point head is equal to temp of next. The temp of next means this will be now pointing to the next node. Temp head is equal to temp of next. Temp's next will hold the head position now. Now then you can free this temp. You can delete this 1. That is what is mentioned over here in your remove beginning. So how will you remove at the end?
Is it necessary to write this free of temp?
Yes. Like, deallocation should be done. No, this is dynamically allocation. Compulsory you have to write. Okay, free temp will deallocate your memory space. That is what we are using linked list.
So in the previous programs also we have to write this.
This is for deletion, like deletion. No, insertion not necessary. Insertion only creation. Anyway, you see, this I am giving you as a different points one by one. But when you write it as a program, you will have everything clubbed together. So in deletion pseudocode, you will be having this free procedure. In insertion pseudocode, you will be having your malloc procedure. In main, you will be calling using switch case or whatever it is to call the insertion, deletion. I will show the entire program together actually to you after the completion of deletion. Then it will be, I think you can get more idea. This is now only as a part-time taking, right? But for deletion, free is important. And for insertion, malloc is important. Okay. So deleting, deleting from the end of the list. I think if anyone can tell, you can answer me how to delete the end of the list. As you inserted in the end, you'll be keeping on moving, right? Similarly, how to delete
if the next pointer is null, then we delete the one. Then we delete the current pointer, and if the list is empty, then we can't delete anything.
So another one, another one you have to do after deleting the last node. That is, maybe if I'm telling it as temp 2, temp 1 and temp 2 I'm keeping. Temp 2 I'm deleting, or temp 1 I'm deleting. The last one which deletes the previous node should become
The last
From
node.
temp one
Last,
dot
no, that
next
is
temp one
null.
of next will
Yeah,
be
next
null.
will be null. Yeah, that is the procedure followed here. So here you can see you are going to delete the third node now. Third node is being deleted. So my two, that is here 3 of next is null. After that, my 2's next should become null. That's the thing. So when you come here, remove n. This is normal thing. Wherever you find whether if your list is empty, this has to be printed. Else, two variable temp1 is equal to head and head you are assigning to temp1 and another one for tracking or for moving. So head is assigned to temp1 now. Now if head is head of next is null, you already know that everything that is the first, that is will be the last node. This condition is for empty list. This if that is the only node in the list. So that will be the only node and that is the only node to be deleted. Na? Your head will become null once your last node or first node and last node are same, means your head is the only node which becomes null after deletion. We are going to see this part. While for tracking the last node or for traversing the last node, you see here temp1 of next node because you have assigned head as temp1. So now what happens is in this diagram, first this is temp1 means your temp1 of next is not equal to null. Not equal to null means this will become, see here, as I told in your insertion in the middle, I told before moving one pointer to here, you should rename this with another pointer. So what it is, what I have done here is temp1 I have renamed to temp2. So when I am moving 1 to 2, what will happen is this will become temp2 and this will become temp1. That is what. So temp1 is assigned to temp2 and temp1 will hold the next one. So likewise it will keep on move. So in this, based on this diagram, I'll tell you. This is initially this was temp1. Now this has become temp2. This is temp1. Then again this will move to temp1 here and this will become temp2 now. And now when I move this temp2, when this has become temp2, you can temp1, now you can check here. Temp1 of next becomes null in this third position, that is when it reaches 3. So when it reaches 3, when it is deleted, what happens? You have to now, as someone told there, you can write temp2's next will be null, because you know that this is temp. Initially this was temp1. When I move temp1 here, this was temp2. So when this was moved here to temp1, this will be marked as temp2. So now this has become null. I'm going to free this temp1. So my 2 of next. So what is the name of this variable? Temp2. So temp2's next is null, and after that I will free the temp1. I think you're clear with this, right? This is you're removing at the end.
Yes, ma'am.
Yeah. Now when I tell about the, so with this I'll end because otherwise it will be a break in the middle. So you can go after 5 or 10 minutes to the next class. I told you next class is Haribabu sir, another one. Whose class is next?
Lata, ma'am.
Snehata.
Yeah, mama. Do you want to leave or should I explain
Ma'am, you
this
can
alone?
finish this topic, ma'am.
What now?
You can finish this topic.
Yes, okay. Okay, thank you. Please listen. So, so deleting a specific node. Deleting a specific node is like you are inserting in the specific node. So you'll be giving a location, and based on that you have to delete that. So I'll directly go to the code. So here you see, here on this diagram alone you see. To delete, change the link. So maybe the same, assuming as head. When it moves over here, this will become the next variable. But when I want to delete this 2, I told you when you are inserting a node also, you need a previous pointer and the next pointer where you have to link A to B and B to C. Similarly, when I am deleting this also, there should be a link from this to this, right? From this to this. So when I need a link from this to this, I have to know, I can either give a variable name for this node, or else I have to give it as temp1's next. I can tell. Maybe for example, I can tell you temp2's next will be temp1's next. Temp2's next will be temp1's next. That is the main concept. See here. Temp2's next will be temp1's next, and after that I will free the temp1. Temp2's next is temp1's next, and So now see here, removing specific. So the value I'm giving over here. Now similar procedure. Head node I'm assuming to temp1, and there is another one variable. Now I'm checking each time. It is starting from the first node. Is that the value to be deleted? That is temp1's data is to be deleted. Maybe 1 if I take is the value 1 to be deleted. Whether I have given the deleted node to be 1 is the deleted node. It is checking. No means only it will then skip over. So is the data to be deleted is equal to the del value. If it is not equal to the deleted value, my temp will move to the next push. And next, another one I forgot. It will check whether it has some other, whether that is the last node. Even though I have given a location, if that is the only node to be deleted, and I have given a location as 2 or something, but already only one node there, condition is also mandatory. Whether that node is equal to null. If that is null means the meaning is it is the last node, and the deleted node which I have, maybe there is only one node is in the list, but my deleted node I have given as 2 second node or third node to be deleted. So my first, this also becomes false now. Now what? Now this also it is not equal to delete. So this is true. Now it will come and check whether I have more elements in the list or not. If I'm not having more elements in the list, it will print that the given node not in the list. Else, if this is also is true, it will come over here and check it out. As I told you, temp1 will move here, and this will hold the value of temp2. Similarly, this pointer will keeps on moving until you find the value to be deleted. Once you find the value to be deleted, at that time this link you have to use. Temp2's next will be temp1's next, and after that you free the temp1.